So let's get started. So let's go to the project. Let's open from the Visual Studio Code. I'm opening a project which we are working on, which is Decade Demo, right? So I think people are still joining and waiting for the approvals. Hope you all got the approvals. Okay. So yeah, yesterday I just have created this file. I'm removing it just for demonstration. I have created it. And there were certain commits. Let me commit them. Uh, Git commit -am file modified. Okay, you can see the git status. It's clean. Ignore that .ds file. That's a hidden file on the Mac system, which is also considered. So let me recollect. Yesterday we were talking about this Git architecture, right? Wherein we have a working directory, staging area, local repository, right? So yeah, changes should move from working directory to staging area, from staging area to local repository, and then from local repository to remote repository. That's how your changes progress. And as of now, we were still on our local. We did not go to remote repository set, right? So this is where we were. So let's go back. Let's take a step back. All right. So till now we have created the files, modify the files, right? Today, let us get into deleting a file, right? How do you delete a file? Suppose I have these three files. Now I realized I don't want to put some file in the local repository. How do we delete this? Git rm file name, file 3. So this will help delete the file. So you can see the file is gone. And if you see status, you should commit the changes. Changes to be committed. Like we discussed, Git works with respect to changes. Means everything is a change. Creating a file, deleting a file, everything is a change, right? So I have deleted the file and committed the changes. Let me commit. Git commit -m, deleted the file. Okay, done. Right, let's suppose now I want to delete the file from local repository, but I still want to keep it in my working directory. Is it possible? Can I do that? Yep. Let's see if I can do that. So there is another command for this, which is git rm cached file do. I want to delete this file from local repository, but I still want to keep it in this working directory. In that case, git rm cached. So you can see the status. Okay, here you can see the file is unstaged and see the status. See, it was telling you changes to be committed. Why was it telling us the changes to be committed? Because like we deleted a file, any change will go through the process. So we need to commit the changes. Let me commit git commit -m deleted from local repository. Okay. So git status. Huh. So why is it showing as untracked now? Anyone? Why was it showing as untracked at this point of time?
File modified.
Why was it unstaged, untracked? When do you see untracked message? Yesterday we have learned.
In the working directory, if it's in the working directory.
For new for newly created files,
Newly
we
filed
see
some.
untracked.
It just works like a new file, right? Because I removed it from staging, I removed it from a local repository. So it just works like a new file, right? So if you want, you can add again and commit it, or else like it is just in the working directory, right? It's not in the local repository. So that's how it works like a new file. But as long or as much as like as I keep on working with it, it will keep on show me as this message. Like it will keep on show me as there is something which you did not add and commit. Okay, please can, because this is a local repository, any changes are this will be version controlled by Git, right? But I don't want Git to track these particular changes. I want Git not to track certain changes, isn't it? Let's suppose this file, I don't want Git to track it. Let us assume that some log file or else some exe file or else some documentation I have taken for the notes. So how do I tell Git not to track this file? Hmm? Right? Like for the reasons, that's the documentation I have taken for the project. I want to keep in that folder, but I don't want Git to track it. Or else it could be a log file, executable file. I just want to keep it in the same folder, but I don't want Git to track it. That's where comes something called .git ignore. So let me add .git ignore. Okay, .git ignore is another file. Now, whichever files you want Git not to track it, add it here, file2.txt. If there are multiple files with some extension you want to ignore, let's say star.log, right? So I may add it here. Okay. So now do you see, like if star means wild characters, if there are multiple log files, I can use this to ignore all log files, right? I can do this. Or else like, let's suppose I just want this one, ignore. Clear? Is this clear? So whenever you add the file name here, your file 2 is no more getting tracked. So let me check the status. Do you see here? Git ignore is being tracked, but file 2 is no more tracked. Of course, git ignore is tracked because it's after all another file, right? So now what I have to do, because it is also another file, git add dot git ignore. Okay. Then git commit -m ignore file added. Ignore file added. Is it making sense? Now file 2 is in the directory. File 2 is not there in the local repository. Git ls files will show, but still it's not being tracked. Git is not tracking it anymore because we told it to git ignore not to track this file anymore. Is the logic clear, everyone? Any questions in this part from anyone?
Priti, so git cache, hyphen cache is still used?
That is a different one, right? That is to remove the file.
Okay.
That is to remove the file. Ignore file is to stop
Totally.
person controlling that file. Yes.
Okay. Yeah,
There is
got
a
it.
difference.
Okay, thanks.
So, yeah. So we are ignoring file to being tracked. Right? That's a very important component. .git ignore. Here I am showing you with sample files. I'll also show you with real files. When we go to our Terraform projects, Ansible for projects, there are files which will hold sensitive data, which should not be version controlled, which should not be pushed to remote. Such files again will ignore with Git. Right? We'll see how it works with those files. Once we start Terraform project, I'll also use again git ignore to use real files. Only file name differs. That's all. The concept remains same. We'll see those use cases as well. Okay. All right. Okay. So now coming back. Yeah. Let us do one thing. If you want to see the commit history, we have a command, right? Git line online. So you can see a bunch of commits were made by now. And at this point of time, let us suppose I want to undo a particular commit. What is meant by undo? What is the meaning of undo? What is the dictionary meaning of undo? Yes, anyone? What is meant by
Reverse the change.
reverse it, right? That means if you have created a file, if you undo means it will be deleted. If you have deleted a file, if you undo means it's created back, right? Same is the case. Any commit ID we can undo. Suppose this is commit A. I can't refer that alphanumeric ID, so I'm referring it as A. Suppose I undo this. Whenever you undo, a new commit ID will be generated, right? Suppose here file is created. When you undo, file is deleted. You can undo this B again. You can undo this again, where file another commit ID will be created, file will be back, you are at the position of A again, right? You will be here. C is same as A. Let me put this is equal to A, right? So yeah. So here the point to note is you can undo any particular commit, which is called revert. Revert. Reverting is nothing but undoing a commit. Undo means you are reversing the changes and you get a new commit ID created. So any change can be reverted. So let's see how to revert it. Means in case if you want to undo some 10 changes, you can do that. Git revert this commit ID A or B, whatever we have referred for. And then it will open this editor. This is called VI editor, a Linux editor. You can just use it easily, where you have to provide a revert message or commit message. Do you remember we have to provide the commit message, right? The same thing I'm doing here, like reverting. You can put your message, reverting the changes. And once you edit this file, escape means insert mode will be gone. Colon WQ exclamatory. That will save and close it. It's very simple to learn this editing this file. WQ exclamatory will close the file and save it. Now if you see the log, you can see new commit ID added or created saying the same, reverting the changes. Got it, everyone? And
A question here, Preeti. So when we are reverting, so this is going back to the working stage, right?
no, you are undoing the committed changes. See, in this commit, what have we done? I have created ignore file. I have reverted it. See, ignore file is gone. File 2 is being tracked. Do you notice your changes are undo? In
Correct. So
7.1, I have created ignore file. I have undo, so that file is gone. It is gone from everywhere, from staging area, local repository, working directory, everywhere. Committed changes are gone. That's why file 2 is there. If I do git status again, file 2 is tracked. Because git ignore file is gone. Got it?
no, I'm still struggling. So by undoing, we are reversing the whole transaction, whatever was there with that ID, be it a new code chain pushed in or file created or file deleted. We just reverse the whole transaction, right?
Right, the committed changes were reverted.
Yeah, the committed changes. For example, I am a developer.
Hmm.
I added 4 lines of new code and then I committed.
Hmm.
Okay, now for whatever reason, maybe my testing was not up to the mark or there is a bug. So I don't want to push it to the next environment. So I am reverting the commit. So when
Right.
I do it, I don't want to lose those 4 lines. So what would I do?
Whenever you are reverting, those changes will be gone, right? But it is a reversible operation. Now my ignore file is gone, or else some lines in the ignore file might be gone. I can get it again. I'll show you how to
I
get it.
see.
But if you understood the part till this much, I'll show you how you can recover those again.
Okay. Okay, that works.
So I have reverted, so the changes are gone, ignore file is gone. So because ignore file is gone, my file 2 is being tracked. Is this much clear, everyone? Now, okay, ignore file is gone, but let's assume I want my file back. Okay, let's see the log. So this is the one. I will revert this again. That's what I'm saying. This is commit A, commit B. I'm reverting this revert. You may call it revert the revert or revert this commit ID, whatever you call it. I'm reverting this. This in this commit file, ignore file is gone. So commit message, if you want to type in escape I, it goes into insert mode. Now leave the message here. Sorry. Reverting the file again. Okay. Save it. How do you save it? Escape colon WQ exclamatory. Okay. So you see the log, right? A new commit ID C. This is called commits. Commit A, commit B, commit C created, right? So you can see this new commit added here, and you can also see here ignore file is back. Do you see that? Because ignore file is back with this file, file 2 is no more tracked. You can check it with git status. Like I told you diagrammatically, commit A, commit B, commit C. Commit C is same as commit A. Why? Because after reverting A, I got B. After reverting B, I got C. So C would be at the same stage as A. Clear, everyone? Any questions, confusions? Feel free to bring it up. Appreciate your quick responses. Whoever understood, please confirm me.
Got it.
Thank you. How about others?
Yeah, got it.
So
Basically,
you are
I was think. Sorry, go on.
you are writing that revert the changes, right? So where you are writing that?
Whenever you run this command, git revert and the commit ID, it will open
Hmm.
an editor, right? It will take
Okay.
directly an editor is opening. There you have to write that message, like commit message. That's a revert message.
Okay.
Any more queries?
Yeah, Priti, can we revert multiple files at a time?
Remember, here we are dealing with commits always, not with the files, not with the individual changes, right? You are reverting the commit ID, means in that commit you might be dealing with one file or multiple files. All those changes will be reverted.
Okay, yeah, got it.
Any more questions? Okay. Okay, so now there is, okay, let me first check the log once again. This is where we are at. Some 10 comments. Now, there is a use case like I just want to undo a bunch of changes or else undo changes that I'm doing from past 5 days, right? Like this, like all these 5 successive comments I want to undo, or else I want to undo successive 7 comments, right? Top successive, top 3 commits, top 4 commits, top 5 commits, means latest commits. I can do that. Like assume like past 1 week work I just want to undo, right? How is that possible? That's where comes reset. Reset. Reset will help you undo successive commit IDs like 3, 4 and all. Right? Also, if you reset, changes gone or gone forever. It's a permanent. You cannot get the changes back. So you should be very careful doing a reset. Reset is called a powerful and destructive command. If you do something here, like you, there are chances of losing the changes entirely. Let me show you. Suppose git reset hard And one more thing, there is something called pointers, head pointer in Git. This head will be always pointing to the topmost commit. When you reset, your head pointer will be moving across. Let's say I want to undo first two commits and I want this one to be the topmost. Give the commit ID whichever you want to be the topmost. So whatever above those commit ID will be gone or lost and no new commit ID will be generated. Because no new commit ID is generated with this reset, you can't undo that reset action. Is it making sense? If commit ID would have generated for an action, you could revert it by reverting that ID. Right? So how is it different from revert? Revert is any commit ID can be reverted. It's not permanent. Like you can undo it again. It's not destructive and it creates a new commit ID so that you can revert it again. So which one is safe? Which one should we use on regular usage on our regular days? Which one we should go for?
Revert.
Always revert is safe way to undo the changes. Reset is very rarely used if you really don't want a bunch of the successive commit IDs, then you should go for reset. Is this much clear, everyone?
Yes.
Right. I think I know one of the scenarios where we would want to reset. For example, if any of the credentials you've put in the file and you don't want to go out or to use, you can do it. But any other scenarios in your experience where you had to do a reset?
Like I told you, right, I'm working on my local repository from past 10 days, so the requirement got completely changed. I just don't want to keep it. When you reset, it's wiped off from the log history also. I don't want to maintain the history as well. In such cases, you can reset. And remember, this is on local repository. We are still on local, not on remote. Right? So this is confined for this type of reset is confined for local repositories. There is another type of reset which we do on remote that is more widely used. This is very rarely used. Okay, let me show you resetting few more commits. So git reset. I want to undo another bunch of commits. Let's say these 4 commit IDs. I may do this one git reset 868 so that all of these will be gone, or else there is another way to do git reset hard. I want top 4, right? So head tilde 4. Okay, that will help you undo it. Right? See here, all of those are gone. That's another way to do it. Right? So it is resetting. Let's say again I want the top 3 should be gone. Only D16 should be the topmost. Done. Right? That's how you can clean them. They are wiped off. Whatever changes happened during that stage were gone, as well as they are wiped off from the log history. Right?
Yeah.
So can you please explain what is this headmaster? What does it signify?
Head is a pointer in Git which always points to the topmost commit in the current branch. Branches we did not learn it. We will get into branching. Just understand. It's a pointer or a marker which points to the topmost commit. So
Okay, so when we are sorry, I'll let you complete.
Whenever you are resetting, because the topmost commit IDs are gone, your pointer is moving, and that's what is reset meaning.
Okay, so scenario we have a head set. So after that we have commit 1, 2, 3, 4, and we just want to delete. Okay, no, sorry, I answered my question. So whatever between the current and the reset head, anything in between will get erased.
No, when you say git reset this one, anything on top of it will be gone.
Yeah, so if we,
Mm.
no, sorry, via the top, for example, in current branch, we have D16. So this is the current one, but I wanted, uh, there are not enough records, but if I wanted something which is two steps behind or two steps under. Yeah, for example, if I want to do CBE as the current head, so B86 will get erased, right?
Everything on top of it will be erased.
Okay, okay,
Commit
clear.
ID. That's what is reset first definition. It will eliminate successive topmost successive commit IDs like top 5, top 2, top 3, whatever you want. If I need top 3, I can write head tilde 3, or else if after if those 3 are gone, this will become the topmost. So I can do git reset that commit ID or git reset head tilde 3. Both will do the same.
Okay.
Understood, everyone? Any questions, confusions on this part? Reset and revert.
Hi, Preeti.
Yes,
We
hello.
want revert the first and third one, we can revert it.
No, not possible. Successive commit IDs only can be. Reverting you are talking about?
Yeah.
You can. One after the other you have to do.
One after we want to mention the ID commit IDs.
Correct. Correct.
Yeah. Okay.
All right. So that is about the revert and reset part. And also I have shown you here. If you observe, reset hard. Hard is the one I'm using. This reset is very rarely used, but there are different types of the reset. Okay, this is far advanced concept and people get confused with the different types of resets. So though we don't use it, I just want to give you clarity on the differences so that at any point of time if you come across you don't get confused, and this chart will help you understand this concept thoroughly. So let me show you that. Reset. Working directory. Staging area. Local repository. Different types of reset. Hard is the one we have learned. There are other types like mixed reset and soft reset. They just work, the command works in the same way. What happens with hard reset means your changes are gone forever. They are gone forever completely. Right? And mixed reset is, suppose your changes are gone from, mixed reset means your changes will be gone from here, whereas your changes will be still present in. So if your changes are present in staging area, is it possible to get it back to local repository? How do you get that?
Git commit.
That's all, right? And mixed reset, your changes are gone from mm, from local repository, from staging area, but your changes are here. So how do you get those changes back?
Git add and git commit.
That's all. Those are the different types of resets, but hard reset is the one that's used. Overall reset itself is very less used. In that, hard reset is used. We don't go for others, but that's a general difference between them. I don't want you to struggle around those concepts, so I'm making that clear for you. This chart will help you understand this concept thoroughly.
Preeti, I have a question. So git hyphen cached also gets the changes from local repository to working directory, right? So is the difference between
Hyphen cached is to delete the file.
okay.
Right. It is deleting the file from staging area, I mean from working directory, but it's still keeping it in working local repository. That's a
Okay.
different thing. Here you are undoing the changes, and those changes are left in the staging area, or they are left in the working directory when you undo. Whereas
Okay.
you
Yeah.
can see hard, it's removing from everywhere. No
Okay.
point of getting them back.
Sure. Got it. Thanks.
So that is the difference between revert and reset. Hope that's clear for everyone. Any questions, anything from you guys on this part before I move on to the next part? Okay. So let's move on to the next part. Um, I'm not doing hands-on on soft and mix. If you are interested, yes, you can try the hands-on. You can also post those screenshots in our WhatsApp group so that we can also take a look at it, right? Give it a try, experiment, explore while doing your hands-on. That's how you learn, right? Take it as an assignment or homework and try it out. Okay, the different types of research if you are interested. That's more than enough. Whatever I'm covering here with respect to Git is more than enough to clear the interview questions, to work in the projects. If you still want to give it a try, definitely try doing the reset part, right? Okay. So git log one line, we just have got two commits. Okay, perfect. Till now, we are creating the files, we're working on them, right? Have you ever noticed when you run the status, you will see something like on branch master. So what is this concept of branch? Right? Till now we are not bothering about it and we were just making the changes. But now let's understand the concept of branch. Branching is a very important and the most important and the powerful feature in Git, which is making it so widely used. Means the branching strategies in Git are so popular and helps different types of projects. So let us understand this. So imagine branch is like a virtual folder. Okay, and whenever you create a local repository, by default this master branch is created. Okay, master branch is created by default whenever you create local repository, and whatever changes you make till now, like any files you created, anything you deleted, all of that goes into this master branch, right? Let's suppose I'm trying to get the marker. Marker is stuck up. Just a second. Just a second. It is stuck up. One second. Give me a second. I have to close and open this. All right. So, yeah. So let us talk about branch. Master branch is the one which will be created by default and any changes you do will go into master branch. Like let's assume in the master branch I have created a file like file 1 and file 2. Let's say file 1 is for functional requirement 1 And there is another file, file 2. This is for another requirement, functional requirement 2. I'm making changes here. Let's say you want this file 1, if requirement 1 to go into, to be released and pushed to remote in the December release. And this should go for June release. How do you separate them? How do you release them separately if you put everything in the same branch? Imagine this is like a default branch. It's like a default folder or a virtual folder. Consider branch as like a folder. So after some time, you don't understand which changes are for which requirement, right? Also, you have to release them separately, which is not possible. Correct? So rather than making changes on the same branch, we can create a copy from the branch master. Let's suppose B1. It's like a folder, right? Assume they are like a virtual folders. So you get the copy here also. Whatever in master, you'll get a copy here. But you make requirement 2 here. You develop requirement 2 here and push this to June. This will go for December. Means you are maintaining multiple releases by this, right? So this is called parallel development or multiple releases, right? You create a branch which is a copy from master. Means branches work like a parallel entities, which allows parallel development, which allows different releases or different versions are possible using this branch. This is a very simple example how branching can be helpful. Not only this, let's suppose there are different environments. You may create separate branches, one for dev, test, and prod. Means for different brand environment, you can maintain different branches, or else we just discussed, for different releases you can have it, or different developers, if they want to make changes, they can have a separate branches created here, right? So this is how the branching concept works. It's very powerful and helpful in reality, where we can maintain different environments. Like we can segregate our code base for different environments this way. And I'll give you an example. Mm, just a second. You can assume a branch like a virtual copy, I told you, right? Imagine. Let me go here and take some folder. Okay, you are seeing Git demo, right? Let's suppose I'm using this folder where I am writing some story. I got some different version. I want to give a different climax to the story, right? Rather than messing up the original one, I can create a copy of it, right? So I made a copy. So I can make a different climax to the second one, whereas a different one in the first one. Means I can maintain two versions of the same story with different climax, right? Correct? Whichever I want, I can publish, or else I can publish both of them. Isn't it? So, okay, tell me one thing. They were same as like when I make a copy. Later on, if I make some changes on demo 2, is it visible on demo 1? Will those changes be
Not
available?
really.
No, right? You have to copy it. Automatically, that means they are same only till you make a copy out of it. Later on, they work like two parallel entities, right? Same is the case here. You maintain branches for parallel development or to maintain different releases, different versions or different environments, or else suppose there are some bug fixes. You may create a separate branch for those bug fixes and release it, right? So that's how branches are helpful in reality. And there is much more coming from these branches. Like from Devops perspective, the story would be like, I'll re-explain this when we talk about CI/CD, but let me just tell you one thing. There will be a develop branch where code changes will happen. Suppose a developer, let's say person A, want to make some changes, has to develop his feature. He will create a branch from this dev. Okay, he'll give some name like, mm, he may give some name to the branch like feature by A. He will develop his changes here. And whenever his changes are done, this will trigger a CI/CD pipeline. right? Any code, do you remember any code change will trigger the pipeline. So it will trigger the pipeline, it will deploy to local environments like dev environments, and if it is working fine, then branches could be permanent or temporary. Means if it is working fine, they will merge these changes back to development environment. It means development is the actual branch, right? So this will be deployed again to some environment. If it is working fine, then this will be merged into test branch. Again, CI/CD for test environment will be triggered. If it is working fine, it is then merged to other branches and so on. Right? That's how your changes move from each level, like from lower environment to higher environment. Got an idea, everyone?
Well, very slight, but I have more questions than answers.
Tell me.
So, to begin with, the master, is it always the replica of production?
Master branch in our context in the local master is created by default, right? General, and we are making changes there. Generally, we don't make any changes in the master. We'll keep master a dedicated branch which will have the copy for prod. Correct. So we don't touch it.
Okay.
Further, we'll create other branches, we'll make changes here, test it over. Once it is working fine, then a final merge will be to master branch, which will be deployed into prod environments.
Okay. So, any change that merges into master
Hmm.
comes after the CI/CD has executed, correct?
CI/CD executes on multiple environments. So yes, first changes will be done into dev branch. CI/CD will trigger to dev environment. Once it is successful, those changes will be integrated back to the next level, next environment. Again, CI/CD will trigger in the next environment. Once it is successful, then the higher environment like master branch, then deploy to prod. So CI/CD works on every environment.
Correct, correct. But when we say that we had a production deployment, it means that code has become part of the master.
Correct.
Okay. Now, with the changes, there are at least two scenarios. Okay. One is a planned change and other is unplanned. So planned is your releases, enhancements, etc., etc. So you'll have a different branch that works on long-term changes. But if something blows up in production, again, you would want a different path so that your planned or long-term changes don't get mixed up with the emergency patch. So do we create one branch for production and one for the releases, or what is the industry
See,
norm?
different strategies are there. Each project uses like different strategies based on their approach. So yes, long-term branches will be there, like release branches. Prod branch will be there, a stable branch. It all depends. That's a developer call how they would decide. Also, that's a, could be at a org level. Certain restrictions, rules designed, so that would be implemented across. But the point to remember is each branch will be deployed to from one environment lower to higher environment, finally goes to master branch.
So normally an org will have their SDLC defined, that they may have a QA instance, then the UAT, then staging of pre-prod, etc. So each of these already have a defined pipeline setup. So do we use the same, like in this scenario, we have the master, then we have a production fix branch, and then we have the release branch. So both of these branch can use the same CI/CD setup, or we define different?
Same setup, servers environments will be different where it is deployed. Same code, same file should be in every branch, except the configurations of those servers would change.
I don't understand. For example, we have a QA instance or QA environment. Okay, there's just one QA environment, and then we have one UAT environment. So although we have two different branches, but for testing, that code has to go through the same environment, which means same servers.
Different servers. QA servers will be different from prod servers, right? QA servers might be having lesser configurations or else local environments.
Correct.
Mm. That
Correct.
that
No,
is
no.
different. Your code in the branches doesn't change.
No, my question is more to the left. So the code changes. We have one set of code that is in dev branch, and then one set of code which is in production support branch. Okay, now both of these code has to be tested by QA team, by UAT, and whatever the downstream. So my code from dev will go to the same QA instance,
Yes, correct.
and for the other branch also, it will follow the same life cycle of QA, UAT, and staging, and then production, correct?
Correct, correct. Also, like
Okay.
it depends on the, like I told you, it depends on certain companies or certain orgs. Like there would be certain stages that would be executed in test environments. New stages might be added up over there. Those stages might not be executed on prod. Those are all the limitations, variations governed by the org at the org level. So those vary. But the actual code remains same. There will be conditions inside the code. This should be executed if it's a QA environment, or if it is a prod environment, this can be skipped. So such conditions would be handled, but it would be more or less the same code that travels through different environments.
Okay. But for example, if there is some release happening, so release have longer duration, so they may already be testing in QA, and then we have this production change coming in, which we need to deploy now, and it has to be tested in the same QA environment. So do we set up a different pipeline for production, or how do we manage?
Different
Uh,
pipelines.
t-
You
t-
have different pipelines for each environment. Like I told you, right? You have different branches. They are going for different environments, means different pipelines. You will have separate pipelines, and those pipelines would be automatically triggered. They can be automatically created whenever you create a branch in your repository, in your GitHub or Bitbucket.
so if we have one QA instance, can we have two pipelines for it?
One pipe. See, it doesn't depends on how many instances, right? Only one pipeline which can deploy to 100 instances. I'm talking about environments, not the number of instances. I'm talking about one pipeline for each environment. That environment might have 10 instances or 100 instances, correct? One pipeline for dev. That could be deployed onto 10 dev servers, single pipeline.
Uh, okay,
Hmm.
I'm still not clear. Okay, for simplicity's sake, this is November. So we have November release testing happening in a QA environment. And now I've been told, hey, we need to deploy a production fix. So we already have a November testing happening in SIT or QA. So how do we test the production fix in QA?
There could be another environment set up to fix this, right? There'll be another test environment to test this. Not on the same server you have to do, right? There'll be different test environments as well. See, you are deviating into another part of deployments. We were talking about the branching strategy. What is a branch and all, right? How this branches goes to the pipeline. Let's wait and see. When we create the branches, that will in the Jenkins, that will give you more clarity. How where each pipeline would traverse through, right? That will give you more clarity. I would say focus on the branching part now, and we'll go into CI part first, then CD part. That gives you better clarity.
Understood, understood. Because with the normal conversation is that with branches we can reduce the environment. So I'm just trying to figure out how what people are doing with the branches to reduce the environments.
Reduce the environment, meaning, like I told you, you'll have only dev environment, test environment, prod environment, right? So these
Hmm.
environments, a particular branch will be pointing to each environment at a time, right? Not that multiple branches will go into the same environment at the same time. Anyway, we'll pick up this once we get to our pipelines. Okay, let's stick to the branching part. Just understand, yes, this is how branching works. You make changes in one branch, you deploy it into a particular environment. If it is successful, you move the same code to the next branch and so on. So, creating a branch, integrating changes from one branch to another branch, right? These are the points to focus on. We'll take up the rest of the queries as we progress through the CI and CD part.
Sure.
Yeah,
So,
I had a quick question, if you don't mind. You
yes,
said the configuration on the server might change. Is that something that we have to worry about, or is it automatic when the configuration changes when you move the branches?
actually, whenever, let's say, it's a dev environment, you are deploying, you are making some changes to dev, right? So in the Jenkins file, when we are doing CI, you can have conditions where, okay, let's suppose this is a dev branch, it should go and deploy to dev servers, right? What is what dev servers? You have a tag, or you are a label, or you have the cluster names, which are dev clusters. So though
Okay.
particular dev cluster itself will have a different configuration, lower configurations when compared with prod clusters, right? So it might be on-prem servers, or else like on-prem clusters, or else it could be on any cloud. So you put the cluster name, or you tag the clusters with a dev, some kind of strategy. It depends on company, depends on orgs. So that's how, like, you have a conditional statements. It's a dev branch, it should go to dev environment. It will pick up
Oh,
those.
so from the beginning is already tags. Like if you make anything, is you don't have to worry about that. You just have
Correct.
to push your dev. I mean your branch. The
Yes,
configuration takes care of itself, right? The
correct.
changes.
There'll
Okay,
be
okay,
a
okay.
separate team who will manage the infrastructure for you, right? It could be even that is also a DevOps role. There might be a DevOps engineer who is working to manage the infrastructure on cloud. Like, let's say, on their own cloud. Companies may have their own cloud. They'll manage the infrastructure. They'll tag the servers with the dev tags, prod tags, test tags, and there'll be list of servers in some portal available. You could write conditions in your Jenkins file such a way that if it's a dev branch, it should pick up dev tagged servers. So,
Okay, so all right, it's written at the base in the Jenkins. Okay, makes sense. Okay.
right. Okay, so coming back, like we were talking about branching, hope the concept of branch is clear for everyone. To list all the branches, git branch command will show you. As of now, we have only one branch. So let me show you creating a branch from master. How do you create a new branch? Git branch, child branch name is, let's say, I'm taking branch name as B1, parent is master. So it will create a new branch called B1, which is a complete copy of a master branch, right? It will create a new branch, which is a copy of master branch. Copy means whatever files master branch have got, whatever commits master branch have got, everything will be copied into B1. It's just a copy. Later on, it can work like a parallel entity, like whatever changes you make in one branch will not be visible to other and so on. But first, let me create a branch. Now, if you see branch list, master star indicates on which branch you are on. I'm sitting on master branch. Okay, fine. Let me switch the branch. How do you switch? Git checkout B1. So see, switch to master branch. Now if you do branch asterisk move to B1, which indicates you're on B1. So if you're on a particular branch, any commands you run are set to be on on that particular branch. See here on branch master. So you can do add, commit, anything. The story is same. But because now I am on B1 branch, all of them are applied or applicable on B1. Meaning, here suppose, okay, okay, I'm on B1 branch. I want to create a new file on B1. So I'm creating file 3. I'm just adding some dummy lines in this file. So same old story. Where is this file? Is it in working directory, staging area, or local repository? Where is the file?
Working.
Working directory means, like I told you, the same story is applicable to all the branches. It's in the working directory. It will be untracked. So what you have to do? Same story. We are well versed with it. What you should do?
Add, commit, push.
Git add file 3, right? Then do git status. Changes to be committed. So what should I do? I would like to give the name as B1 file changes, something like this. Done. Git status on branch B1, untracked files. Right? So you can see on branch B1. Okay, ignore this one, but yeah, like it's clean. And let me do one thing. Okay. Right. So git log one line. I have this new commit, right? BA76. Do you think this third commit available on master branch? Do you think they are available on master branch?
No.
Let us see. Let us switch to master branch. How to switch the branch?
Checkout.
Git checkout master. So I'm on master. Now if I do log means log of master. Do you see the file 3 is no more? You don't see the third commit. So it helps us understand that they work like two parallel entities. If you make changes in one branch, that's not available or visible automatically on the other branch. Is this much clear for everyone?
Yes, I have a quick question. So when we creating a new branch, for example, from master, so all the metadata, for example, the commit IDs, etc. So everything is copied, right? There's no difference.
Right, right.
Okay.
So now they work like two parallel entities. I made some commits in B1 which is not available on master. Okay, fine, perfect. Like I told you, branches could be of two types. Permanent branches, temporary branches. Permanent branches means like for each environment you may want to maintain a separate branch like dev branch, test branch, prod branch or release branches and all. They could be permanent. Or else, let's suppose I want to try out something, test something. Rather than interrupting the dev branch, even though it's a dev environment, I would like to try it out on some other branch, a new feature I want to try out. I might create a new branch and try out there, right? So such branches, like I will try out if it's working fine, I would integrate into the original one. Later on, may delete that branch because it's very important to keep the safe housekeeping methods. Like stale branches should be removed because branches also makes the project expensive. If you just keep maintaining too many branches, your pipelines become drastically slow. They occupy a lot of disk space. Also, they are costly with respect to Bitbucket. If it is Bitbucket, yes, you have to pay for each branch in the enterprise version. So to avoid all these challenges, we'll clean up the branches when not used. Like for the draft kind of things, we may just clean up the branches, right? So let us do one thing. Let's suppose now I have done something on this B1. Let's suppose B1 is a temporary branch. I want to integrate the changes now from B1 to master. How to integrate changes from one branch to another? What is that called as integrating changes from one branch to another? Anyone?
Merge.
Integrating changes from one branch to another is called merging, and the command is git branch. Okay, source branch and the destination branch is the syntax. What is meant by source branch and destination branch? Sorry, the command to integrate is git merge source and destination, right? So what is source? Source is the branch from where you want to bring the changes, right? Meaning I want to get the changes from B1 into master, right? So the command is git merge B1. And what is the destination? Where do you want to bring the changes?
Master.
Master. Source is from B1 and destination is I want to get the changes into master. So this is the command to integrate the changes. Git branch, source and destination, B1 and master. Let me run this. See, it tells you updating the changes, created, inserting. So like it tells you the changes were merged. And if you see here, you can see the third commit sitting in master. Got it? This is called fast forward merge or automatic merge. And if you want to see the log of any other branch on which you are not currently, you can put the branch name here. So now it is same. That's called integrating changes from one branch to another or merging the changes from one branch to another. Is this much clear? Any
Yeah.
questions?
Like, in Terminal, how we can create a branch? Can you give me the command? I missed that.
This is the command to create a branch. Git branch, child branch or new branch, then parent branch or old branch, whatever you call it. This
Okay.
will help you create the branch from one other branch.
So is there a way to do selective merge? Because it could be that there are 10 different developers working on a branch, for example, a release branch. So there may be 10 different feature branches coming out of the uh, feature branch, and we just want to merge one particular commit from from B1 to master.
Generally, whenever you run the commit command, whatever commits in the source branch are there, all those committed changes will be into the destination branch. If you want to
Okay.
if you want to merge only specific commit, that's called cherry pick commit. It is possible, that's called cherry pick commit. You pick up whichever commits you want, means from where you want to merge. The command is available in our YouTube channel also. It's just a simple command. You can give it a try if anyone interested. In our channel, I have placed those videos for cherry pick command. It's not so extensively used. We don't use it regularly, so that's why I'm not covering it here. You can try, give it a try.
Okay, so normally we merge the whole branch. Okay,
Yes, that's the best.
thanks.
Any more questions from anyone? So we were talking about very important concepts today, like we have learned about git ignore, we have learned about revert, reset, different types of resets, correct? And then we were talking about branching and then simple merge concept also we have seen, simple straightforward merge, right? There is also another type of merge which you will get through conflicts, where you get the conflicts, right? And that is a bit advanced part. And also at this point, I would like to remind you, we were still on this local repository. We did not go to remote yet. Because these are all things we need to learn in remote before we go to, sorry, in local before we go to remote. Any more questions? Okay, let me just take a. Hope you all got your LMS access. Have you all submitted your quiz yesterday?
Yes.
Okay, you have to go to your LMS and submit your quiz, and you can retake the quiz so that any questions you have, anything you want to resolve, like you want to recheck your understanding, that will help you. So go through the quiz here available under Git version control systems. And that will be a secondary recording where you can find lab exercises, quiz and all. So I would request everyone to go through this quiz immediately after the class every day, right? That will help you to register and validate your learnings. And the assignments for mandatory. Have you all set up your Git? Is the Git setup done and started with the hands-on? Can I know how many of you started the hands-on on Git?
Yes.
Git setup is done.
That
Yes.
setup is done.
Yes, sir. Yes, ma'am. Done.
Right. So have you also started the hands-on?
Yeah.
Yes.
That's great. That's great to know. So this is the day 2 part, whichever I'm covering here today regarding the revert, reset, all of these things comes in here. Right? The branching, right? The simple merge concept. Conflicts, merge with conflicts will take up in the next class, day 3, as it is day to complete all these exercises, assignments before we pick up the merge conflicts. Once we learn merge conflicts, we'll also see conflicts on remote and all. So yeah, go through these hands-on, and remember, I would like to make here one more point clear. We do have GUI for Git, means there's a graphical user interface for Git where you can do everything with drag and drop. But if you just learn that UI part, you will never learn the commands, you will never learn the concept, right? So always, for any tool, always focus on learning the CLI part, the commands. That's how you will learn the concepts. Once you know the CUI, once you know the concepts, once you know the repo, the subject, GUI is a cakewalk. It's a self-explanatory for any tool. And majority of the tools in reality we use CLI only, not GUI. Because I get this question from some participants in every batch, so I want to make it clear for everyone. Any more questions?
The GUI, do they use it in the industry, or is just as an alternative?
I haven't used it. In my experience, I haven't used it in any company or anywhere. But I do hear in some projects they use it and they end up using it but don't know it, but no knowledge on it. That's what is my experience, what I heard and what I saw. Like
Oh,
some basic smaller projects where they might be using the GUI, but that wouldn't help candidates to gain technical expertise. Anything I should clarify for anyone?
so in a
Mm.
project, do they tell you like which one is going to be the branch for the dev and all that, the documentation and all that, or like how do you know you're in the dev and the production environment?
Like there'll be some org specific restrictions on how branching should work. So that's what you will see. But there'll be definitely different exceptions, different projects, each have their own strategy. So whatever agreed upon for that particular, what do you say, for that particular domain, that's the strategy they follow. And if they are following some particular strategy, if you're a DevOps engineer, obviously you will be engaged into those meetings and those strategies would be aware of. If it is support, yes, support, when there is a support ticket, they'll also share that information of how they want to have their branching strategy. And yes, documentations will be there, complete documentation on how each branch should work with respect to particular domain or a project.
And who normally manages the Git administration, like creating users, giving them access, etc.?
Actually, if you take GitHub as a software as a service, right? So that would be managed by Git, but managing users, all of them will be handled at each project level. Each project, the application owners or admins will have access to do that. Not everyone,
Okay.
project owner or the admin, one person will have the admin access to do that. And by the way, we are still on local repository. We did not get to GitHub, which would be actual the working as remote repositories. So, any more queries?
Yeah, for DevOps standpoint, right? When they first get on the project, do they say you're going to be doing this particular tool, or they can assign you to any tool, or like for the whole project, or do they have like your job, your main thing is GitHub, or you're going to be doing the Jenkins, or you do everything, or just sometimes some specific tools?
Again, that is an org level decision. Like organizations will have their own tool set up depending on the budget they have, depending on the resources, depending on the requirements, and depending on the design of their applications, right? So that's a very high level, architect level discussions, decisions made on which tools to be used and all. That will be cascaded to every team, every project, and to the DevOps engineers as well. That's a high
I
level.
meant, okay, I meant in terms of like, is in maybe a big project, do they have like maybe a team, all they do is the GitHub kind of work, or in general you do the all the different tools? I'm just curious.
All different tools. A team would be working with all the multiple tools.
Okay.
As a DevOps engineer, you'll be making changes in GitHub, create a pipeline with Jenkins, right? Deploy or containerize your applications as a Docker containers on Kubernetes cluster. That Kubernetes cluster could be on on-prem, and those on-prem servers, either Kubernetes or on-prem physical servers, could be managed by some configuration management tool like Ansible, and the cloud environments could be set up for Terraform, and monitoring tools would be there to monitor each tool stack, each services, each applications, where Prometheus, Grafana, or Splunk, Datadog, so many different monitoring tools are there. That's where those tools comes in.
So in the class, we can be using. I mean, in the real world, we're gonna be using all the different tools in different environments. It doesn't you just switch from one to the other, not specific.
You mean different monitoring tools are used or only one monitoring
No,
tool?
no, I mean like the different tools you said, like all these different tools in the project. You could be working on all. You could be doing Git today. You're doing Jenkins tomorrow. At any time. It's not like you're just gonna be doing one particular tool
Correct.
or as an expert or something. Okay.
Correct. You use all the tools. Yes. So that's the tool chain, right? Like you have these tools integrated that makes your pipeline. So the problem could arise on from any tool or at any stage in the pipeline. So we should be working on different tools or different stages in our pipeline. Okay. All right then. Anything else you want to know? Focus on the concepts we are covering step by step. Okay, you will be definitely having so many questions and all. Like as we progress through those topics, those questions could be answered well and things fall in the place. So, yeah, just keep going, right? Keep mastering your topics day by day, and eventually we'll get to the point where you get a complete clarity as you connect these dots, right? All right, then. If any more questions, I will answer. Otherwise, we can wrap up here for today and we'll continue tomorrow at the same time. Complete your hands-on, complete your assignments, re-listen the recordings once again if you are new to these topics. And any questions, post in the WhatsApp group or bring it up for tomorrow's discussion. Okay. All right then. Thank you all. Good day. Bye everyone. See you
Thank
all.
you.
Thanks, Preeti.
Hello.
Yes.
I'm in US. There's holiday on Thursday. Is the class on Thursday?
Thursday. What is there on Thursday?
They have in the US. They have the Thanksgiving holiday.
Okay, on Thursday. It is just 1 hour class, right? I'll not take 1.5 hour. I'll just wrap it up a bit early on that day rather than skipping it. Okay, we'll have
Okay.
1 hour class, a quick
Oh,
wrap.
okay. Okay.
All right. All right then. Good day. Bye everyone.